Welcome in Dark Core. It is difficult to find a material object or a substance that would excite the consciousness of mankind as much as this one. No wonder. It has so many prizes in the most category. Very valuable prizes. For example, this is the most expensive substance that humanity only possesses. The production of 1 gram of it, according to NASA estimates, would cost $100 trillion. That is 5 times the annual US budget. It is 2.5 trillion times more expensive than gold and 3 trillion times more expensive than black caviar. This substance is the best explosive in the world. In terms of the strength of the explosion, nothing can be compared to it, even theoretically. It is the same as it's impossible to surpass the speed of light. And it is also the most mysterious substance. So mysterious that if our world was created by God, then the existence of this substance allows us to accuse God of bias. Let's take a closer look at this most mysterious and intriguing substance. It's called antimatter. The prefix anti means that it is the complete opposite of our familiar matter, our familiar world, to which each of us belongs. So opposite that when it comes into contact with ordinary matter, a grandiose explosion occurs, which is called annihilation, which in Latin literally means complete destruction. Matter and antimatter will completely disappear, turn into light, into energy. Matter will disintegrate not even into atoms, but into particles much smaller than them. To understand which monstrously huge amount of energy is released during annihilation, let's give a few figures. US thermal power plants burned 419 million tons of coal in 2021 to generate 844 terawatt-hours of electricity. If we had a power plant running on antimatter, then it would take only 17 kilograms of antimatter to produce this amount of electricity. Just imagine the difference. A huge mountain of coal, which would take more than 4 million railway cars to transport, and an ordinary travel bag with 17 kilograms of antimatter, which can be lifted by one person. And no pollution, no huge emissions of carbon dioxide. Greta Thunberg would be pleased. And such a grandiose reservoir of clean energy was discovered quite by accident. Prior to this discovery, humanity did not even know about it at all. In 1930, a 28-year-old English theoretical physicist was solving the equation of electron motion at speeds close to the speed of light. It all came down to solving a quadratic equation that described the value of the electron's energy. But a quadratic equation, as you know, has 2 roots, which means 2 solutions. With one root, everything is clear, a well-known electron corresponds to it. And what did the second, negative root mean? Well, energy can't be negative, can it? Many scientists, having learned about the result obtained, dismissed it. The second solution simply has no physical meaning. That is, they acted like ordinary school children who, when solving the problem of how long the 2 buses will meet and getting a positive and negative time value, tell the teacher that the second value has no physical meaning. But Dirac insisted that the second solution must also have a physical meaning. There must be a particle exactly like an electron, but with a positive charge. Namely, an anti-electron. Moreover, the Englishman at the same time predicted the annihilation of the pair, electron plus positron, with the release of a large amount of energy. Oh, how he was criticized for his stubbornness. It is enough to quote Heisenberg, by the way, a close friend of Dirac, the saddest chapter of modern physics is and remains Dirac's theory. I consider it simply rubbish that no one can take seriously. But the truth eventually triumphed, and in 1932 K.D. Anderson discovered this anti-electron, which he called the positron, that is, the positive electron, positive plus electron. So Dirac was right. Does antimatter exist? After all, if there is a positron, then there must be an antiproton, that is, a particle exactly the same as a proton, but with a negative charge. There must also be an antineutron. We combine an antiproton with an antineutron, launch positrons around them, and now we have an antiatom. And a lot of antiatoms create antimatter. And that means there is also annihilation, a huge source of energy. We already gave an example of this huge energy at the beginning of the video. A peaceful option, so to speak. And the military prospects are no less grandiose. The annihilation of 1 gram of matter releases 100 trillion joules of energy. This is equivalent to detonating a 10-kiloton atomic bomb. Hiroshima was destroyed by a 15-kiloton atomic bomb. For what it would take only 1.5 grams of antimatter. But many scientists stubbornly refused to believe in antimatter, just as they had previously refused to believe in the positron. Yes, there is a positron, but it is a one-of-a-kind particle. The whim of the creator, in a manner of speaking. And antimatter does not exist. If it existed, then there would be antiplanets, antistars, antigalaxies. And we would definitely notice them from the grandiose cosmic explosions. We would never have nights. The whole sky would be on fire. And in general, the laws of our world are symmetrical. For the universe or God, everything is the same, matter or antimatter. At the time of the creation of matter after the Big Bang, the same number of atoms and antiatoms should have been created. And if so, then immediately there would be a grandiose bang, and instead of the universe we would have a boundless ocean of light and elementary particles. Therefore, the experimental discovery of the antiproton in 1955 at the newly launched Bevatron accelerator was a rather non-trivial result. In 1956, the antineutron was also discovered in the same accelerator. And the last doubts have disappeared, antimatter really exists. And when the first antiatoms were discovered in 1965, they were antihydrogen atoms. It did not cause such a hype. And the Nobel Prize was not given for it. And scientists who completely refused to believe in the existence of antimatter, apparently intuitively understood that this question is too fundamental and can shatter our ideas about the world. It's the nature of antimatter, it has tremendous destructive power. But for now, we will keep the intrigue on this issue, and first we will explain some interesting facts about antimatter. Fact 1. Why is antimatter considered the most expensive in the world? We said before that 1 gram of antimatter costs about $100 trillion. Why such a staggering price? For 2 reasons. First, the enormous complexity of production. To extract such material, very precise and energy-intensive technologies are needed. To create 1 gram of antimatter, it would take a whole year to use all the electricity generated on the planet. And this is approximately 25 million billion kilowatt-hours of energy. To date, the inefficiency in the production of antimatter is enormous. Given the costs of obtaining antimatter, only 1/10 billion of invested energy can be returned. If scientists could collect all the antimatter we have ever produced and destroy it, the energy produced would not even be enough to boil a cup of tea. Secondly, the huge costs of storing antimatter. The world we live in is made up of ordinary matter. As we know, annihilation occurs at the contact of opposite types of matter. Fact 2. Antimatter is closer to you than you think. One should not think that antimatter is hidden somewhere in the depths of the cosmos, hundreds, thousands and millions of light years away from us. Small amounts of antimatter are constantly raining down on Earth in the form of cosmic rays, consisting of elementary particles. These antimatter particles reach our atmosphere in amounts ranging from 1 to over 100 per square meter. There are other sources of antimatter that are closer to us. For example, bananas. They produce antimatter by emitting 1 positron about once every 75 minutes. This is because bananas contain small amounts of potassium-40, one of the isotopes of potassium. The decay of potassium-40 sometimes produces a positron. The human body also has potassium-40. Therefore, each of us emits more than 4,000 positrons per day, or about 180 positrons per hour. Fact 3. Many people associate antimatter with the cosmos and flights to the stars. Thanks to science fiction. Antimatter is indeed an ideal fuel. Probably, many have seen a photo or video of the launch of the Saturn V rocket, which delivered astronauts to the moon. Remember this Colossus 110 m high, 10 m in diameter and weighing 2,965 tons. 90% of that weight was fuel. Can you imagine how much fuel you need to get to Mars? Poor Elon Musk. But if humanity had an engine running on antimatter, then it would take only 1 milligram. And since we are talking about the cosmos, let's talk about the most intriguing thing related to antimatter. Why is there so little of it in the universe? Where are the anti-stars, anti-galaxies? Where, after all, is the anti-universe, a mirror image of our universe. After all, how nice it is to realize that somewhere out there, beyond some line, your double lives, your exact copy. And if something in your life is not right, maybe, on the contrary, everything is okay with them. Admit it, it's nice to have a kindred spirit, even if it's billions of light years away from you. So why isn't there anything like this? There is a fundamental law in the world, which has not yet been proven by anyone, but it was not broken in any experiment for a long time. It says that there is Captain symmetry, from the capital letters charge, parity, time, meaning the behavior of any physical system, including the entire universe, should not change when all particles are simultaneously replaced by antiparticles, parity and time inversion. In other words, for matter and antimatter, all physical laws must be the same. Therefore, the number of particles and antiparticles must be exactly the same. But the catch is that matter and antimatter do not tolerate each other. On contact, they annihilate. But then, as we said above, the universe would simply not exist. But since you are watching this video, it still exists and is not going to explode, at least for the next couple of billion years. So where did the antimatter go, which should have been formed after the Big Bang in the first moments of the existence of our universe? Scientists had to admit that there is still a certain asymmetry and that more matter was formed in the Big Bang than antimatter. Calculations show that it was enough for every 10 billion identical quark-antiquark pairs to have just one extra quark. Over time, these millions of pairs annihilated, and from one extra particle, all the matter of the universe came out, which we can see around us. It turns out that CPT symmetry is not fulfilled with absolute accuracy. But it had to be proven. We needed to find a physical process in which the symmetry would be broken. And such a process was found. In 1956, Chinese-American scientist Qiancheng Wu, also known as Madame Wu, conducts her famous experiment, which was later named after her. The experiment proves that the parity conservation law does not work in weak interactions. That is, the laws of physics are different for our and the mirror world. For some reason, for God or nature we turned out to be a priority. As to why, so far, no one has been able to give an answer. But if it was different, if there was equality, then our universe, and therefore we, people, would not exist. So, equality is not always a good thing. What do you think about this? Write about it in the comments below this video. And if you enjoyed it, please press a like to appreciate our work. And do not forget to subscribe to our channel, there are still a lot of secrets of the universe that we will talk about. Thanks for watching Dark Core.